morning, everybody. We are continuing small perturbation equations of motion for longitudinal case. And if you recall, we knew that mu dot equal to minus mg cos theta 1 plus fx was the equation along x direction. Similarly, m w dot minus u1q is equal to minus mg theta sin theta 1 plus fz was the second equation, and the pitching moment equation was Iyy q dot equal to m. And what are these fx, fz, m? They are the perturbed aerodynamic forces fx, fz, and perturbed aerodynamic moment m. How do they generate? Suppose the airplane is at steady state, let's say cruise is our case. Then if I disturb it, small disturbance if I give, then naturally it will have pitching motion, there will change in the velocity. So accordingly, moment as well as forces along x, z direction also will change, moment will change, and these are perturbed moment. What is our aim? We want to see as the disturbance vanishes whether this perturbed quantity u, w, and q, they come to 0 or not, so that in a way the airplane has come back to its own equilibrium, right? So it's dynamically stable. And what was our approach? Approach was we wrote fx, the function of u by u1, alpha by alpha, then q, alpha dot, etc. And once we did this for fx, fz, m, we got some dimensional derivatives, and then we wrote this equation as, to be more precise, what we did was we, for fx, using those stability derivatives, we wrote this as q1s minus cdu plus 2cd1 to u by u1, then minus cd alpha minus cl1 into alpha, then minus cd delta e into delta e. And for fz we wrote like this, we derived these expressions, q1s, and then write minus cl alpha plus 2cl1 into u by u1 minus, this should be here, it should have this sort of a curly bracket because q1s is common here. So this is u by u1 minus cl alpha plus cd1 into alpha minus cl alpha dot into alpha dot c by 2u1, then minus clq into qc by 2u1 minus cl delta e into delta e. And for this equal to moment, the pitching moment we expanded as q1 as c bar, because now it's a moment, so c bar will be there. Cm u, we realize Cm is very important derivative, especially for supersonic case, and then plus Cm alpha into alpha plus Cm alpha dot into alpha dot c by 2u1, then Cmq into qc by 2u1 plus Cm delta E into delta E. Okay? And then we did a little bit of algebraic adjustment. We divided each term by m. So I have got a u dot here. I divided each term by m. I got w dot here, and each term by Iyy. And then we wrote this equation as u dot equal to minus g cos theta 1 plus xu into u plus x alpha into alpha plus x delta E into delta E, and xu, x alpha, x delta E we define as a dimensional derivative. Similarly, w dot minus u1q is equal to minus g theta plus zu into u plus z alpha into alpha plus z alpha dot into alpha dot plus zq into q plus z delta e into delta e. Note down this xu, x alpha, x delta e or zu, z alpha, z delta e, etc. are dimensional derivatives. That is why I don't mind writing z alpha into alpha. Then I have got q dot equal to mu into u, m alpha into alpha plus m alpha dot into alpha dot plus mq into q plus m delta e into delta e. Okay, all these things we have done. Now the question comes, what to do next, right? Before we go for next step, we realize that all these xu, x alpha, zu, z alpha, etc., all these derivatives are dimensional derivatives, are dimensional stability derivatives. This is important. For example, if I take m alpha, the corresponding non-dimensional derivative is Cm alpha. Okay. If it is alpha dot, then the corresponding non-dimensional derivative is Cm alpha dot. Okay. So once we have this, this is the equation of motion where I have got u as the perturbed u, w as the perturbed w, and q as perturbed q. Okay. Now for completion, what I will do, I will also post the exact expression of xu, x alpha, x delta e, etc. for your ready reference, which I will not write here, but you know very well what is xu. You need not require anybody's help. Xu will be just simply divide this equation by m. So xu will be q1s by m into minus cdu into u by u1. So u1 will come. So xu will be, very simply you can see, which we have shown last time also, xu will be minus q1s by m into minus 1 into cdu, or let me write like this, q1s minus cdu plus 2cd1 divided by u1. So that will be xu, because if I divide by m here, so I get u1 is by m minus this bracket term into u by u1. So u1 I have taken denominator. So this becomes xu. So this term xu into u gives me this complete term divided by m. Okay. So please do it yourself, and you see it's nothing big mathematics or mathematical expedition. It's as simple as dividing by m. Okay, let's come back here. These are the three perturbed equations of motion. So what to do next? What is our aim? Our aim is to solve this equation and try to find out the stability characteristics of the system in longitudinal mode. Okay, so we'll do that. Now we'll do another trick, because we know this is a linear system because we're talking about small perturbation theory. So we'll use Laplace transform, and that is defined as f of s is 0 to infinity e to the power minus st into ft dt. So this is a Laplace transform. It transforms time domain into frequency domain. Okay? What is the advantage? You'll see, if you recall Laplace, if this is the operator, Laplace of x dot is nothing but s x of s minus x of 0, which is the initial condition. For a linear system, we can neglect the initial condition, but for a stability point of view, for a linear system, it doesn't depend upon initial condition, right? So we don't really care for it. So if I see it here, what is happening? This is a first order differential form, x dot. Now this is x of s. So now this has become almost linear form, in a sense algebraic form it will come. So if I take a Laplace transform here, what will happen? For u dot, it will be s u of s equal to minus g cos theta 1 into theta of s, right? Now we take Laplace transform on this equation, and then you will see, of course, we have done some mistake here. Here there should be a theta, part term theta, plus xu into u of s plus x alpha into alpha of s plus x delta e into delta e of s. You see here, if I understand the Laplace of x dot is s of x of s, then Laplace of u dot will be s. What will be Laplace of u dot? Laplace of u dot will be s u of s, that is u in frequency or Laplace transform of u, ut. This will minus u of 0. We said we don't care about initial condition because we are studying the stability aspects of a linear system. So it doesn't depend upon initial condition. So u dot become Laplace of u dot become su of s. So here u dot is su of s minus g cos theta, and theta is here theta of s, then xu into u of s, x alpha into alpha of s, x delta into delta e of s. Similarly, you can do it here. Take this Laplace transform, second equation, third equation, and then you can write finally a neater form of equation in a matrix form. This will become, once you take the Laplace transform of all the three equations, let me write what you will get. You will get s minus xu into u of s, then minus x alpha into alpha of s, plus g cos theta 1 into theta of s, right, equal to x delta e into delta e of s, right? We'll not directly write matrix form now. First we write the equation in standard form, then you convert into matrix form. The second will be minus zu into u of s, then s u1 minus z alpha dot minus z alpha into alpha of s. The third term will be, another big term will come. This is minus zq plus u1 s plus g sine theta 1 into theta of s equal to z delta e into delta e of s. And the third equation will become minus a mu into u of s minus m alpha dot s plus m alpha plus this m alpha into alpha of s, then s square, it will be s square minus mq s theta of s equal to m delta e into delta e of s. You could see that we have not used q of s, right? You are not getting anywhere this term q of s. Why? Because we know q is equal to theta dot, right? So q of s will be equal to s theta of s. Under small disturbance approximation, these things are fine. Okay. Now we'll make a trick and try to make it in a matrix form. So what is the best way to do? Is you simply put here matrix sign like this, take out this us from here, take out this alpha s from here, theta s from here, and then you write this, take this also, write this, okay? And write this as u of s, alpha of s, theta of s, like this, is equal to x delta e into delta e of s, z delta e into delta e of s, and m delta e into delta e of s. I'll be sending you, testing you all these small algebraic manipulation or adjustments. Because you understand Blackboard, it will become too heavy to handle this. So what is this? This is an equation form Ax equal to b, and this is a linear system, you know. And you know for a linear system, whether the airplane is stable or not, that can be easily decided by studying its characteristic equation. That is the punch statement. Number one is linear system, and for a linear system, if you want to find out whether it is stable or not, best way to do is find this characteristic equation and find the roots of the characteristic equations, and then you can comment whether system is stable or not, dynamically stable or not. So we'll do that, and if I now again use my or our matrix understanding, so I can find out that what is the determinant of this matrix equal to 0 will give me characteristic equation, characteristic equation, right? So what is the determinant? If I put the determinant, I will get the equation in this form: as4 plus bs cube plus cs square plus ds plus e equal to 0. Do you see what do I mean? What is the determinant of this? You know how to find determinant. So first term will be s minus xu, right, into this minus this. Similarly, second term will be this side eliminate, so this minus this. Like that I can find the determinant, and I can club them in the form of a, b, c, d, e as constants, and I can write this equation in this fashion. For the completion, I will just give you one value of this coefficients. Let's say if I do the determinant part of it and put it to 0, what is the a I will get? You will see soon you will get, and you can do yourself. We will not do on the blackboard here. A will be a minus u1 minus z alpha dot. Similarly, b will find that will be minus u1 minus z alpha dot into xu plus mq minus z alpha minus m alpha dot into u1 plus zq, like this, you know. Similarly, c, d, e, f and all. And I will write the expression of e also here. I will erase this part. As I told you, this thing you have to do once. That's all. After that, you forget and try to understand what is the physical interpretation of it. If I see the expansion, E will come like this. E will come as G cos theta 1 into m alpha ZU minus Z alpha MU plus, or this is like this, plus G sine theta 1 mu x alpha minus xu m alpha, something like that. This will come. If you expand, you will get it. Okay? Let us focus here. Once we have got such a characteristic equation, which is of fourth a to the power 4 cube 2 1, right? There are numerical ways of finding this root. You have to solve this equation numerically and find what are the values of these roots. And depending upon roots, you can comment on the stable or not, right?